All right, in question 5, you were asked to find the length of the arc AC. And remember, when you see that word length, we are talking about a linear measure from A to C, not an angular measure. We could set up a proportion because the arc length, the ratio of the arc length to the circumference is proportional to the ratio of the central angle of the arc to the entire circle. So you might have seen this proportion where we will say the central angle, I'm going to just abbreviate that, the ratio of the central angle, that over 360 degrees, because all circles have 360 degrees as they're in the interior of the circle, I should say. That ratio is equal to the ratio of the arc length to the entire circumference. So to solve this problem, you need to know how to find the circumference of a circle and then how to solve a proportion. And we've spent a lot of time solving proportions this year, so I'm confident that you'll be able to do that. Okay, so first, let's go ahead and find the circumference. We said we could find the circumference by either of two formulas, 2 times pi times the radius, or just pi times the diameter. And these are really the same equation because 2 times the radius is, in fact, a diameter. So if you look at what you're given in the picture, you're given that the radius is 9. We know that's not a diameter because a diameter would go all the way across. All right, so our radius is 9. That means that our circumference is going to be 2 times pi times 9, which is the same as 18 pi. And we're going to leave everything in pi notation. So now we can go ahead and fill out our proportion. Our central angle, meaning this angle, is 100 degrees. We know the circle has 360 degrees in it. We are trying to figure out the arc length. And I know that the arc length will also have pi in it because it's part of the circumference. So what I like to do is I like to think of it as x times pi. So I can just solve for the multiplier of pi. And then we know the circumference itself is 18 pi. All right, so there's a lot of methods we could use here. We could simplify this fraction. So 100 over 360, I could simplify that to 10 over 36, or even 5 over 18. It doesn't matter if you simplify it or not if you're using a calculator. But we're going to simplify, or excuse me, we're going to cross multiply. And when we cross multiply, I'm going to actually cross multiply with the original 100 and 360 degrees just for this example. So my cross products end up being 100 times 18 pi is equal to 360 times x pi. And if we end up with pi on both sides of our equation, we could divide the pi off. And in fact, if you are my student, I maybe told you to just forget about pi when you're cross multiplying. All right, so now if we take what we have in our proportion, what's left, we're at the statement of equality, that 100 times 18 is equal to 360x. So 100 times 18 is 1,800, and that is equal to 360 times x. We can divide both sides of the equation by 360, and we are left with 5 equals x. So be careful now because our arc length is not the number 5, but if you go back over here and look at that proportion, we said our arc length is going to be whatever we get for x times pi. So our arc length is going to be 5 pi